Okay, so now we're going to use stoichiometry and apply it to finding percent yield. So percent yield is going to measure the efficiency of our reaction. Remember, the whole point of a reaction is to get as much product as you can. So this percent yield is going to tell us if that was actually achieved. It's going to be the ratio of our actual yield to our theoretical yield expressed as a percent. So since we're doing a ratio, there's going to be division. I'm going to get a percent, we're going to multiply by 100. The theoretical yield is the maximum amount of product that can be formed from your given amount of reactants. And this is going to be found using stoichiometry. So when you're asked to find a theoretical yield, you're going to have to use your stoichiometry. The actual yield is the amount of product that forms when the reaction is actually carried out. Now, this is normally what's going to be found during an experiment. Obviously, we can't do an experiment for every single practice problem we do, so typically this will be given in the problem. So let's try one of these. They want to know what is the percent yield. If the actual yield is 0.51 grams and the theoretical yield is 0.75 grams. So remember, to find our percent yield, it is actual over theoretical. So they told us our actual yield is 0.51 grams. And they were nice. We don't have to do any stoichiometry. They told us our theoretical yield is 0.75 grams. We are going to need a percent because we're finding percent yield. So you're going to multiply by 100. And so 0.51 divided by 0.75. We need to keep 2 sig figs. That gives us 0.68. I forgot to multiply by 100. So that's going to be 68% is our percent yield. Now, you are not always going to be given the theoretical yield. Typically, you're going to have to find the theoretical yield. So they want to know what is the percent yield if 13.1 grams of calcium oxide is produced from 24.8 grams of calcium carbonate. Check your reaction, make sure it's balanced. We have 1 calcium and 1 calcium, 1 carbon, 3 oxygen, and 1 plus 2 is 3 oxygen. So this is balanced. So we have our actual yield, and that is going to be this. The reason we know it's our actual yield because it says is produced. Okay, so we know that that's our actual yield because we're comparing our products now. Limiting reagent compares reactants, percent yield compares products. So that means we're going to have to start with our reactant, and that's going to be this one. So there it is, the reactant. So 24.8 grams of calcium carbonate. Grams always needs to be turned into moles. So 1 mole of calcium carbonate is going to go in the numerator, and you're going to have to find the molecular mass. So calcium weighs 40, carbon weighs 12, oxygen is 16, and we have 3 of them. That gives us 100 grams. Since we're going from one substance to another, you're going to have to use your mole ratio from your balanced equation. We're trying to get to the calcium oxide here so that we can compare this to our theoretical yield that we're finding. So calcium oxide is going to go in the numerator. We're trying to get rid of the calcium carbonate over there. So moles of calcium carbonate is going to go in the denominator. Coefficient for both is 1. And we don't want our answer left in moles. We need it in grams so that we can do a comparison. So that means we're going to have to find grams of calcium oxide. Molecular mass is always equal to 1 mole of that substance. So grams, calcium is 40. We have 2 of them plus, oh, we don't have 2 of them, sorry. 40 plus 16 is 56. So now we can do our math. 24.8 divided by 100 times 56. Keeping sig figs, we got 3 sig figs, so it is 13.9 grams of calcium oxide. And this is our theoretical yield. So now to find our percent yield, we're going to do actual, which is the 13.1, over theoretical, which we just found to be 13.9, times 100. And that means our percent yield is 94.2%. So you should not get anything over 100% if you're solving a problem on a worksheet, but in the lab you may end up with something over 100%, and that's due to human error, calibration error. So if you didn't heat something long enough, you may end up with a little bit more reactant left than what you would like. That's going to cause you to have a higher percent yield than 100. So error in an actual lab will cause you to have more than 100, but for a worksheet,